Now in this section, section 4, we're going to be working with continuing to factor quadratic equations, but now they're in the full standard form, so y is equal to ax squared plus bx plus c. And we're going to do this by factoring again, using special patterns again, and we're also going to find zero. So we're doing the same things we did in the previous section. What's different is that now we have a different leading coefficient. In the last section, as we started into factoring, our leading coefficient was always 1. The factors of 1 are 1 and 1, and so when you combine them, doing your insides and outsides, doing FOIL, they don't have any impact on the problem, because when I take the factors of the constant and multiply them by 1, they don't change. So it will be a little more complicated, but we're still basically doing the same task. The key vocabulary from this is a repeat vocabulary word, monomial. Again, we're talking about a monomial is a single term, so something like 2x squared. This is a monomial. It has a single term. Mostly we were sort of establishing monomial as an idea in the last section, and in this section we're going to be factoring monomials out of equations before we begin. Okay, so again, the type of problem that might be solved using the skills we're working on in this section is a problem like this one. The surfboard shop sells 45 surfboards per month when they charge $500 a surfboard, but if they lower the price by $20, they sell 5 more surfboards. So what we want to try to find out is how much should they change the price, how much should they lower or raise the price in order to maximize the amount of monthly revenue that they receive, so the total amount of money they get. So we'll be working on this problem as we finish up this section. So before we go into that, let's get just again the same way we started before. Let's just look at the possible factors, but now we're looking at both a and c. So the leading coefficient, that's a prime number. The factors are 1 and 2. And of the constant here, that's also a prime number, 1 and 3. So that's very simple. Here we've got 4 and 4, so I could have 1 and 4 or 2 and 2 for my leading coefficient, and the same, because it's the same number, for my constant. A little more options here, 1 and 15, 3 and 5. We could have 1 and 8, 2 and 4 for 8. Okay, so what's going to happen now when you start thinking about outsides and insides, I could be using the 1 and the 4 here and either of these over here. So now we have 4 different possible outcomes when we're talking about the different insides and outsides that we might be looking at. So let's go ahead and do that. We look at this one. This was probably the simplest because they're prime numbers. 1 and 2 are the factors of the leading coefficient, and 1 and 3 are the factors of the constant. So when you start thinking about what could be my outsides and my insides, I could have 1 times 1, which would be 1, and I could have 2 times 3. I could have 1 times 1 plus 2 times 3, right? So this times that and this times that. That would be 1 plus 6. That would give me 7. So you notice, though, that I want to add up to 5, not 7. But if I have 1 times the 3 and 2 times the 1, 2 times 1, 1 times 3 is 3, 2 times 1 is 2, 3 plus 2 is 5. That's the number that I wanted. So it's important, though, once we've figured out these different ideas, that these are the factors of the leading coefficient, and these are the factors of the constant. Okay? This is the set that worked, but now we want to put them correctly into our binomials. It's still basically the same, except there's more variation of where they might be. So remember, we're talking about outsides and insides from FOIL, right? Here are my firsts, here are my lasts, outsides and insides. Okay, so my firsts, I could have 1 and 2. And then outsides, right? 1 and 3 were the outsides. And then the insides are 2 and 1. So then I'd have x here and x there. And remember, this sign means both the signs are the same. They're both pluses. There we go. If I want to double check my work, 1x times 2x is equal to 2x squared. That's my correct first. 1x times 3 is 3x. That's my outside. My inside is 2x times 1. That's 2x. And my last, 1 times 3, is 3. And when I simplify, 2x squared plus 5x plus 3, that's the same equation I had to start off with. That checks. So there I have it. Okay, let's do another problem. So this one's different because I've got a minus here, right? So again, we've got 1 and 4, and we could have 2 and 2, and the same for the other 4, 1 and 4, 2 and 2s. So remember, these are going to be my firsts, these will be my lasts, and then we want to start checking my outsides and insides to see what's going to work to get a difference of 5. Okay, so if we start looking at this, I can try different things. I could have 4 times 4, right? That's one of the ones I could have. I could have 4 times 4, and I could have, well, 1 times 1. 16 minus 1 is 15. No, that's not the number I wanted. I could have 4 times 1 and 1 times 4, but then that would be the same number and I'll get a difference of 0. Right? So I could have 1 times 4 minus 4 times 1. That would be 0. So this guy didn't really work. It failed. Right? If I have 2 times 1 and 2 times 4, right? I could have 2 times 1 minus 2 times 4. That's 4 minus 4 again, or sorry, 2 minus 8. 2 minus 8 would be the difference of 6. In this case, it would have been negative 6. That didn't work. And again, if I do 2 times 2 and 2 times 2, those are going to be the same. It's going to equal 0. So you notice that I've tried all the different possibilities. And none of these came out to be 5. So what that means is this is non-factorable. Okay, for now we're just going to say it's non-factorable. But as we move forward through this chapter, we're going to learn how do we continue through and solve when we have non-factorable polynomials. Okay, so let's go ahead and look at another example. Right? We could have 1 and 15, or we could have 3 and 5. We could have 1 and 8, or we could have 2 and 4 to create, right? These again are my firsts, these are my lasts, and when we start talking about outside, inside, we want to have a difference of 2. Okay, so you see if I do, right, 15 times 1 minus 1 times 8. It's going to be 15 minus 8. That's a difference of 7. And it's not what I'm after. I could do 15 times 8 and 1 times 1, but very obviously that's going to have a massive difference, right? It's not going to be 2, so I'm not even going to try that. I could have 3 times 2, which is 6, minus 5 times 4. So 6 minus 20, that's going to be negative 14. That's not going to help me. I could have 5 times 2 minus 3 times 4. So it's 10 minus 12 is negative 2. Oh, that is what I wanted. I wanted to get minus 2. I wanted a difference of 2. That's going to work. So these could be my outsides, and these can be my insides. Okay? You can see that right? When we start working on putting the binomials together, I know because of this sign that one of them is a plus and one of them is a minus. I know I have to finish out with minus 2. I need minus 12. So what's going to make that happen? You'll notice that what becomes positive or negative is the factors of the constant. Okay, those are what determine things. So this 4, that's a factor of the constant. It has to be here. And the 2, let me go ahead and color code those so that we stay really clear. These are the factors of the leading coefficient. That's what we used here. Those are my firsts. These are the factors of my constant. Those make my lasts. So if I get confused, if I just keep focused on that, I know I have to put them so they make lasts. And these have to make firsts. Well, remember, I actually have it, the way I've written it, it's backwards. The way these have to be actually the insides, and these have to be the outsides, because you see the 4 is on the outside. So this 3 has to go over here in the other binomial. If I put the 3 in this binomial, it'll never be multiplied times the 4. Okay, that means the 5x goes over here. Okay, so these become insides, those become outsides, and now if I test 3x times 5x, 15x squared, I got the right first. I have 3x times minus 4, that's minus 12x. I have 2 times 5x, that's plus 10x. And then I have 2 times negative 4, that's minus 8. I have the correct constant. When I combine outsides and insides, I get 15x squared minus 2x minus 8. That is what I originally started with. It checks. So this is my correct factorization. Okay, we still have, these are the same patterns we looked at before. We're still looking at the first term and the last term to see, are they perfect squares? This has a minus, so I'm looking to see, is this the difference of 2 squared? So is 4r squared the square of anything? It is. It's the square of 2r. And is 25 a perfect square? It is. It's the square of 5. So now I know that 2r would be a, 5 will be b, so I can have 2r plus 5 times 2r minus 5. So the only thing that really changed is you'll see that before we just had a leading coefficient of 1 up here. So it was a little simpler to be looking at, oh, is that a perfect square and where does it go? Nothing's really changed. It just has a few more elements in it to make it a little more complicated. Okay, same thing here. I want to check to see, is this a perfect square? It is. It's 5t squared. Is this a perfect square? It is. It's 3 squared. And now I have to check, is this 30t, is it 2 times 5t times 3? Well, that's 2 times 5t is 10t times 3 is 30t. Yes, it is. It checks. So this is the square of a binomial. Now remember, like we did before, I take this term, 5t, I take this sign, minus, and I take this term, the 3, and that makes the binomial that's squared. Okay, if I want to double check my work again to make sure I did it right, 5t minus 3 times 5t minus 3. 5t times 5t is 25t squared. 5t times minus 3 is minus 15t. Minus 3 times 5t is minus 15t. And minus 3 times minus 3 is plus 9. When I combine like terms, 25t squared minus 30t plus 9. Do I have the same equation? Yes, I do. That checked out. So this is my answer. Okay. Now, as we work on into polynomials, because we're going to be working with polynomials in chapters 5 and in chapter 6, and we started off with very simple quadratic functions. We're going to work into more and more and more complex functions. What's important is that you start developing basic habits of checking to find the simplest way to get through the problem. Most of the time, this doesn't mean it's the only way to get through the problem, but it's the difference between taking a problem and making it very simple or making it more difficult. So you always should check to see if you could factor a monomial out of each of the terms before you begin. And you notice one quick thing to look for is even numbers. That's an even number. That's an even number. I know I can factor a 2 out of that. So if I factor the 2 out, this becomes 2 times 16v squared, I'm sorry, not x, v squared, minus 1. Okay, now this is a smaller polynomial, smaller quadratic equation than the one I started with, and now I continue on working with this. I've got no middle term, so I'm going to check to see if this is the difference of two squares. This is a perfect square. It's 4v squared. This is a perfect square. It's 1 squared. So that's the difference of two squares. So it would be a plus b, 4v plus 1, times a minus b, 4v minus 1. And now I've fully factored. Right? Again, if I multiply this all back out, it should turn back into this initial equation. I'm not going to take the time to do that, but that's something you can always do to check to see if you're correct. This one's a little more confusing perhaps, but if you look at this, 21x squared, right? The other things to check. I have an x squared here, I have x there, but no x here. So I won't be factoring the variable out. If the variable is in all three terms, you definitely want to factor it out. But if we start looking at these coefficients to see if they have a common factor, they do. This is 7 times 3, this is 7 times 10, and this is 7 times 4. So I can factor a 7 out of everything. And that would be times 3x squared minus, I'm sorry, not 10, it's 7 times 11, minus 11x minus 4. Right, and then we want to look to see if we can factor this. So I know that I'm going to have x. I know I'm going to have x. This is a minus, so I know that one of my signs is a plus and the other one's a minus. I'm looking at the factors of my leading coefficient. It's a prime number. They're 1 and 3. I want to look at the factors of my constant. I have 1 and 4 or 2 and 2. And I want to have a difference of 11. Well, I can see really quick that 3 times 4 is 12. So if I do 3 times 4 minus 1 times 1, then that'll be 12 minus 1. That's a difference of 11. Okay, so again, thinking about these are my firsts. There's a first and a first. These are my lasts, the 1 and 4. Last and last. So I just have to make sure I put them where they go. Right? It's easy sometimes as you get, you feel pressure or you're taking a test, and to start getting these things confused, you have to make sure they go in the right place. Okay, remember we want to come up with minus 11. So what I want to have is I want to actually have negative 12 plus 1 is really what I want to have. So again, what determines whether or not it's negative, it's always going to be the constant. So I know that the 4 has to be with the minus sign, which puts the 3 in the other binomial. So these are our outsides. Then these are my insides. The 1 goes here and a 1 goes there. And if I want, so those are the insides, these are the firsts, and these are the lasts. If I want to check this out, I could have 7 times 3x times x is 3x squared. Okay, that's the right first. I have 3x times minus 4, that's minus 12x. I have 1 times x, that's plus 1x. And I have 1 times negative 4, that's minus 4. That's the correct last. And when I combine my middle terms, 7 times 3x squared minus 11x minus 4, the minus 11, that checks. So this was a correct factorization. Okay, so after you factor a monomial out, then you continue on with the things that we've already learned. It's just that factoring the monomial out makes the number smaller. Sometimes if you can factor the variable out of each term, it makes the polynomial smaller, and it makes everything a little bit easier. Okay, to finish up, let's go back to our problem with the surfboard. Inherently here, we want to talk about revenue. So the revenue is going to be equal to what? We know that the revenue is going to be equal to the price times the number of surfboards. Right? So when I take a look at this, I go, okay, well, how do I determine the price? They started off with $500 a surfboard, so it's 500 bucks minus, because we're talking about decreasing the price. So for each decrease in price, it's $20, right? So if X is the number of decreases, then 20 times X would be the amount of money we've reduced. And then for each, we sold 45 surfboards. For each reduction, we increase the number of surfboards, so that's plus 5 surfboards times the number of increases. Right? And if we want to solve this, then I would go ahead and I'd multiply it out and then see if I can factor it. So if I have 500 times 45, that's 22,500. And then 500 times 5x is plus 2,500x. And then minus 20 times 45, that's minus 900x. And then minus 20 times 5 is minus 100x squared. All right, when I simplify this all out, I'm also going to put it in the correct order. Remember, the x squared goes first. So I have minus 100x squared. And I have 2,500x minus 900x, that's 1,600x plus 22,500. Now, when you think about this polynomial, right, we want to maximize monthly revenue. So we want the highest possible number. This is a quadratic function. And if you remember, we learned in the first section that if the leading coefficient is negative, it opens down. So the graph of revenue looks like this. So the point at which revenue is maximized is the vertex. Remember, the vertex is the highest or lowest point. It's the highest point when it opens down. So this vertex, that's the point of the highest revenue. So what I really need to find out is I want to find the vertex. So I'm going to take this formula, right, the opposite of B over 2 times A. So I'll have the opposite of 1,600 over 2 times negative 100. So that's negative 1,600 over negative 200, which is equal to 8. Now we want to answer the question. So remember, X was the number of times that we reduced the price. So I reduced the price 8 times. 8 times. Each reduction was $20. So I'm reducing by $160. My initial price was $500. So $500 minus 160 is equal to $340. So A is the correct answer. Okay? Always important to remember, I wrote a really good equation. This scenario models all the information that's in here, and I solve it and I get a solution, and my solution is 8. But 8 doesn't answer the question. The question is, what price should they charge for the surfboard? So I use the 8 to find out how much we reduced the price, and then I can answer the question, $340. Okay?